Good afternoon. Thank you for joining us for a presentation of the draft Offshore Wind Cable Corridor Constraints Assessment Report. I'm Kate McClellan-Press, a Senior Project Manager with NYSERDA's Environmental Research Program. And with me today to give an overview of the assessment is a team from WSP USA. Before we begin, a few reminders for participants and some background on this webinar. Next slide, please. First, if you are experiencing any technical issues, please contact Sal Graven at the email address at the bottom of this slide. This webinar is being recorded, and the recording and presentation slides will be available at the RFI website listed here. All participants have been muted. We will have time for Q&A following the presentation, so please use the Q&A function to submit your questions for the speakers. And next slide, please. Today, we are going to briefly go through an overview of the assessment, goals, the roadmap to the draft assessment report, key findings, and then we'll follow up with how to provide input to the request for information. Next slide. And next slide. Thank you. So first, we wanted to go over the purpose of this assessment and provide a little bit of context. So first, the Climate Leadership and Community Protection Act commits New York State to a minimum of 9 gigawatts of offshore wind by 2035 in the context of zero emission electricity by 2040 and a reduction in greenhouse gas emissions by 85% below 1990 levels by 2050. And the New York State Climate Action Council included projections of a potential of 20 gigawatts of offshore wind by 2050 in their draft scoping plan for the Climate Act. So this offshore wind cable corridor constraints assessment is needed to help better understand the constraints of siting cables in New York State waters at landfall and along overland routes to pave the way to meet the at least 9 gigawatts minimum mandate. Next slide, please. And the broader goals of this assessment, again, are to document and increase the understanding of potential constraints to offshore wind cables, both undersea and overland. This includes environmental, technical, and social constraints, as well as ways to mitigate risks and impacts. And then lastly, this assessment will inform potential future policy actions to help achieve the mandated 9 gigawatts of offshore wind by 2035. Next slide, please. We would like to announce today that the comment period for the draft assessment request for information has been extended from October 14th to October 28th, 2022. So that's a 2-week extension. Next slide, please. And before I hand it over to the WSP team, I'd like to mention the things that this draft assessment does not include. It does not address all aspects of potential cable corridors. It focuses on issues most likely to present risks and opportunities relevant to achieving 9 gigawatts of offshore wind. It does not identify complete routes or corridors. It does not rank or prioritize various routes, landfalls, or points of interconnection. It does not address whether the cables in state waters will connect to radial, meshed, or backbone transmission concepts. It does not substitute for or prescribe any analysis of alternative routes as required as part of regulatory review processes. And lastly, it does not assess the capacity of any of the points of interconnection substations or upgrades that might be necessary at any location. So now that I've covered what the assessment does not include, I would like to hand it over to Janine Witkin, a Assistant Vice President at WSP USA.
Thank you, Kate. Yes, as Kate mentioned, I'm Janine Witkin. I'm the project manager for the WSP team and the VHB team that has been doing stakeholder outreach with NYSERDA. And for our presentation today, each of the WSP folks who are reporting on different aspects of the report will introduce themselves. And as Kate said, the assessment report that we are seeking comment on reflects the past year, I'm sorry, you could go to the next slide, of evaluating spatial data and obtaining input from a range of stakeholders. And I'll provide this quick overview of the assessment report organization. The first section is really all of our background information, foundational to the analyses and the process. Section 2 is really fundamentally a constraints analysis of specific areas, and rather than specific routes, using quantitative and qualitative data on environmental and spatial characteristics. Section 3 is an impacts analysis that focuses on those resources considered of high constraint and most likely to affect cable routing. Section 4 is a summary and findings from looking back at the work that was performed. And in the next slide, you see the study area for our work really encompasses state waters, um, divided into the areas that an offshore wind cable would approach the substations. So those are the South Shore and Long Island Sound and New York Harbor, and then the substations or POIs either in New York City or Long Island. In the next slide, this is really a key input to the assessment process. Early in the process, NYSERDA established the cable working group made up of the agencies you see listed here to provide input, feedback, and guidance. And although this report does not substitute, as Kate said, for regulatory analysis, you can see the role of each agency and their permitting jurisdiction was central to characterizing and understanding the constraints as well as impacts and opportunities. We met virtually and in person almost monthly in the past year, where the WSP team presented on each step of the analysis, each approach area, each section of the report, and the working group provided feedback, guidance, and direction. Also, as you'll see in the next slide, a foundation of the report in the next slide is input that we obtained from other sources. In particular, the request for information that NYSERDA issued at the end of 2021. We had meetings with NYSERDA's technical working groups and also received public comment on that. Another example, although the focus of our analysis is on state waters, we recognize that cables may not always stay in state waters. So one of the stakeholders we reached out to are the neighboring states, New Jersey DEP and Connecticut Department of Environmental and Energy Protection. The report also builds on the extensive prior work that NYSERDA has done through the master plan, as well as the power grid study. For example, the power grid study was the source of the substations that we analyzed for particular paths in our report. And in addition, NYSERDA is sponsoring a vessel traffic risk assessment, which provides us some context on projections for future vessel traffic because it could be a constraint to construction of cables. In the next slide, just a little bit of technical background information to convey some of the key concepts for installation of the cables and how that factors into impacts as well as avoidance, minimization, and mitigation. There are two types of cables used: the high voltage alternating current or high voltage direct current. They are distinguished by the diameter and the amount of power that they can carry. And ultimately that if you want to convey the same amount of power, you would need more HVAC cables than you would HVDC cables, because the HVDC cables require one trench for almost 3 times the electrical capacity of the AC cables. It reduces impacts and allows more cables to be installed in the same space. Because of that, and based on the power grid study recommendations, the Public Service Commission directed NYSERDA to require use of HVDC where appropriate. And the majority of our report assumes that future cables will be HVDC. So with that, I'm going to turn it over to Katie Evans from WSP, who will describe the process we went through to do that constraints analysis.
Right. Thanks, Janine. Good afternoon, everyone. As Janine said, I'm Katie Evans. I'm the Deputy Project Manager for this effort and also lead the onshore analysis. So we'll use this as a segue into our overview of the constraints analysis to really set the foundation for the remainder of the discussions today. Next slide, please. So the constraints analysis process for both the offshore and onshore is summarized here and was generally the same between the two. The process started with the identification and compilation of a range of constraint spatial data, including natural and environmental resources, socioeconomic resources, and existing infrastructure, all with the potential to affect or be affected by construction, operation, and maintenance of offshore wind cables. That list of spatial data was shared with the cable working group for their review and comment, and the public also had a chance to comment on that during the previous request for information process. The second step of the process was to delineate zones for analysis. This was done for both the offshore approach areas as well as the overland and landfall area. And Steve and I will talk in more detail on that process in the next slide. But the third step here on this process slide is through the GIS analysis, the percent area of each resource within each zone was calculated by dividing the area of each resource by the area of each zone for the GIS layers that were associated with a particular resource. And for the onshore analysis, there was a slight difference there. The percent area of each resource was calculated by dividing the areas of each resource by the area within the total right-of-way within a zone. And we'll walk through what those rights-of-way were in just a moment. So then using that ultimate percent area coupled with professional judgment of the team as well as input from the working group, each resource was ranked as high, medium, or low. And where more than one GIS layer may have represented a particular resource, an overall ranking was applied. Next slide, please. Steve McLeod and I will tag team this slide, so I'll pause for a moment to let Steve introduce himself and to go through the undersea portion of the slide.
Good afternoon, Steve McLeod here. I'm an environmental scientist specializing in coastal and offshore resource assessments and permitting. For the offshore approach areas, we delineated zones to focus the analysis in areas with similar resources and constraints related to potential cable installation. These zones could potentially facilitate a corridor for transiting cables and/or cables making landfall near substations that are potentially feasible points of interconnection. The zones were initially delineated to avoid important resources and critical constraints where feasible. However, we also considered highly constrained zones that may need to be crossed to achieve the target of delivering at least 9 gigawatts of offshore wind power. In a few highly constrained zones, we also reviewed subzones to focus on more distinct options for potential cable alignment. The intent of this zone-based analysis is to support the identification of potential corridors or other policy actions that reduce the potential effects on resources. However, the designation of these zones is not meant to preclude the potential for installing cables through other areas. Next slide, please.
Oh, actually,
Oh, I'm
after you
sorry,
jumped,
back to
that's
Katie.
okay.
Back to Katie on the previous slide.
Thank you. I'll just jump in quickly and go through the onshore zone delineation process and the definition of an onshore zone. It's really an area which includes multiple rights of way that connect a landfall point to one or more points of interconnection. So they were delineated to provide some continuity from the offshore landing zones that Steve discussed to, as I said, one or more points of interconnection. Zones optimize the use of existing rights of way, which I'll define on the next slide, actually in 2 slides, I believe, and exclude certain resources to the extent practicable, where complete avoidance is necessary or preferred, like in the case of wetlands, critical species and sensitive habitats, and environmental justice communities. Next slide.
Okay, this figure shows the 3 offshore approach areas and the zones that were evaluated within each approach area. This includes 5 zones along the Atlantic shoreline of Long Island, 9 zones leading through Block Island Sound and Long Island Sound to the northeastern part of New York City via East River, and 8 zones leading into the greater New York Harbor area. The inset figures show the subzones that were considered in zones L-2 in the Long Island Sound approach area, as well as zones H-2 and H-3 in the New York Harbor approach area. These will be touched on further later in this presentation. Again, while the zones have been defined based on certain factors like cable landing feasibility, proximity to POIs, and precedent set by existing cables or pipeline landings, we acknowledge that options for routing may be considered outside these zones. The zones were limited to New York State waters, but resources and constraints in adjacent state and federal waters were also recognized. Next.
Okay, and this slide provides an overview of the overland zones that were delineated. There were a total of 25 zones, which include 2 on Staten Island, several in New York City, and multiple zones that traverse Long Island falls both on the southern and northern shores. Zones are generally larger on Long Island and have a mix of the right-of-way types that you see there in the text box. And zones are smaller in New York City and are comprised of the largest proportion of existing transmission lines as well as arterial roadways. Zones with landfall along the south shore of Long Island would involve crossing intercoastal waters. Those zones were drawn as narrowly as possible, as you can see there, to adhere closely to existing crossings of those intercoastal waters due to their ecological sensitivity. Due to the extent of development and corresponding spatial limitations onshore, the analysis focused on maximizing the use of existing rights of way for potential cable co-location opportunities. We used 4 categories of rights of way: electric transmission, both above and underground existing lines, arterial roadways, Metropolitan Transportation Authority passenger lines, as well as natural gas pipelines. The report does acknowledge that other rights of way might also be suitable. For example, some of the defunct aqueducts that exist in and around New York City, but those were not considered as part of the assessment. And also to note that the analysis assumes the use or expansion of existing rights of way and not the creation of new rights of way. Lastly, the analysis included the 21 points of interconnection that are identified on the figure by the red squares. And these are the representative substations considered potentially feasible points of interconnection in one of the prior studies that Janine mentioned earlier, the New York Power Grid study. Next slide, please. So now we'll get into really what the meat of the draft assessment is, which is section 3, to provide you with an overview of how it's set up and what you can find there. Next slide. So section 3 is set up similar to a typical environmental assessment or EIS, which some of you may be familiar with. The existing conditions for each resource are described first, followed by a corresponding discussion of potential impacts. Section 3 is organized by approach area and by resource. So you'll find all of the undersea approach areas first, followed by the onshore approach area. The existing conditions discussions provide an overview of the resources present within a zone and subzone in the case of the undersea. The descriptions largely reflect publicly available GIS data, cable working group knowledge of specific resources, as well as prior experience from relevant projects that may overlap with our study area. The level of detail of the existing conditions discussions reflects the rankings I discussed earlier, high, medium, and low. So where resources rank high, for potential constraints, you'll see a greater amount of detail there as needed to address options for avoidance, minimization, and mitigation. So on the other end of the spectrum, resources ranked low are not discussed or maybe minimally described because careful offshore wind cable siting and implementation of best practices are expected to be able to avoid and minimize impacts to those resources. With respect to impacts, potential impacts from cable installation, maintenance, operation, and decommissioning relevant to siting multiple offshore wind cables are described for each resource. Those discussions focus on locations where resources are ranked high or to consider cumulative potential constraints where multiple resources are ranked medium within a zone or subzone. Next slide, please. So complete avoidance of impacts is the primary or preferred approach for siting of offshore wind cables. However, construction, operation, maintenance, and decommissioning activities cannot always avoid impacts, particularly for highly constrained resources or locations. So that's why the minimization and mitigation measures really provide the methods for protecting and offsetting impacts to affected resources. We wanted to first start out by defining those terms. So minimization is an action taken that reduces the severity of an effect of an unavoidable impact on a resource. And mitigation is an action that compensates for, either through replacement or offsetting, the loss of a resource or resource function, such as the purchase of a wetland mitigation bank credit or contributing to a mitigation fund. You'll see throughout Section 3 that there is an inventory of what we call the M&M measures, which were compiled based on the working group's experience, previously issued Article 7 certificates, and pending applications for similar offshore wind and cable projects. So those really provided a comprehensive list of the types of measures that should be implemented with these projects. So throughout the development of the assessment, minimization and mitigation measures were refined to reflect current understanding and expanded where needed to facilitate locating multiple cables. Lastly, where applicable, expanded measures or innovative concepts to avoid, minimize, and mitigate impacts are identified for the constraints of most concern. Next slide. This is where I'll pass it off to Noelle Mathias.
Thanks, Katie. Good afternoon. I am Noelle Mathias, a marine biologist specializing in threatened and endangered species. In the next few slides, we're going to discuss the key findings of each undersea approach area, beginning with the South Shore, then Long Island Sound, and wrapping up with the New York Harbor. Within the South Shore approach area, high-ranking constraints include commercial and recreational fishing and existing linear utilities. Recreational fishing occurs in all South Shore zones and charter fishing in most zones. Commercial fishing occurs in 3 of the 5 zones. And an example of a high percent coverage of existing linear utilities is seen in zone S1, Smith Point. Next slide, please. On this map of high constraints in the South Shore approach area, mapped New York recreational fishing areas are represented by the red stippled areas, and mapped New Jersey prime fishing grounds are represented by the orange hash mark areas. Existing utilities are mapped with various color lines and symbology depending on type. Chartered cables are in purple, chartered pipelines in dark red, and the Neptune submarine cable in yellow. And finally, Empire Wind 1 and 2 propose export cable routes in the blue and black dotted lines, respectively. You can also see how the zones were drawn in along the South Shore to avoid constraints where possible, hence the trapezoidal shape of the blue outlined zones near the shore. The minimization measures identified for use in the South Shore, such as time of year restrictions, proper burial techniques, and parallel routing to minimize resource fragmentation, were determined to be adequate. Additionally, there is an overall lack of space constraints along the South Shore. This combination of factors make multiple cable landings along the South Shore a less difficult option than other approach areas. Next slide, please. The Long Island Sound approach area had nearly 3 times as many constraint categories ranked high compared to the South Shore approach area. The most significant constraints include marine geology with hard bottom, complex symmetry, and swift currents, marine commercial and recreational uses with fishing, ferry routes, and existing linear utilities, navigation areas, particularly in zone L6, which is the upper entrance to the East River, aquatic and biological resources, including cold water corals, essential fish habitat, submerged aquatic vegetation, and threatened and endangered species. And lastly, marine cultural resources, including obstructions and a high % coverage of wrecks in zone L5, which is westernmost Long Island Sound. Next slide, please. These are 2 of the most space constrained and difficult areas in the Long Island Sound approach area. Western Long Island Sound and the entrance to East River on the left, and the Harbor Hill Moraine on the right. The symbology is the same in both figures. Hard bottom is represented by the yellow-green polygons, and areas of scour from swift currents are visible in the dark blue areas in the right side of the right figure, just above that small L1 label. Areas of heavier vessel traffic are shown in the red and yellow areas in the slightly transparent base layer in each figure. This highlights the ferry routes from Orient Point in the right figure and navigation channels in the left figure. Significant coastal fish and wildlife habitat is represented by the red hatched polygons as seen in the upper right corner of the right figure and bays in the left figure. There are areas of SAV present around Orient Point in the lower left corner of the right figure, and wrecks are represented by the small pink triangles sprinkled throughout the left figure. Use of the routing principles will be vital in space-constrained areas and beneficial to minimize potential impacts in non-space constrained areas. But the compounding effect of significant constraints present for aquatic biological resources, marine geology, marine commercial recreational uses, navigation areas, and marine cultural resources throughout the approach area still present significant challenges for the installation of multiple cables. Any proposed export cable routes considered by developers would require close coordination with agencies and stakeholders, and likely detailed project-specific and innovative routing and installation approaches. With the high biodiversity in Long Island Sound and abundance of unique habitat, particularly in the Harbor Hill Moraine and Stratford Shoal, additional baseline studies on habitat for planning purposes would be beneficial. Thank you, and I'll hand it back to Steve.
Hi, one moment, please. Sorry, just had a moment of a cough. So this slide, actually, for Long Island Sound, I believe we are turning it over.
We should go forward.
Oh, the next slide.
Yeah.
Right.
There you go.
Okay, there we are. Thanks. Sorry for the up there. So in the New York approach, harbor approach area, we identified the extent of designated navigation areas and the volume of vessel traffic as the most significant constraints for installing cables in the subsea environment. While these were considered most critical to overall cable routing, several infrastructure crossings, strong currents, and shallow bedrock may also pose challenges to cable installation, especially in the relatively narrow waterways of East River, Kilvancole, and Arthur Kill. Further challenges are present at shore crossings due to the extensive waterfront infrastructure and shoreline protection projects, including several bulkheads and restricted shoreline workspace options. Next slide, please. This figure focuses on the zones considered most challenging but potentially most important to facilitating multiple cables for delivering at least 6 gigawatts into New York City, which is a target identified in the Power Grid study. This includes Zone H2, the Narrows, and Zone H3, Upper New York Bay. Connecting waterways with other important constraint considerations include the Hudson River, Zone H4, East River, Zone H5, and Kilvancole, Zone H7. The study zones are outlined in blue, with subzones shown with light blue cross-hatching. The anchorage areas are shown with red shading, while the federal channels are named and outlined in orange. The assessment specifies a principle of avoiding channels and anchorages where feasible. However, it is not possible to install cables through the Narrows in Upper New York Bay unless one or more anchorage areas and/or channels are crossed. There are examples of coordination that have allowed for successful installation of linear infrastructure through these areas, notably the Bayonne Energy Center cable that runs through the northern portion of Upper New York Bay, and the progress that Empire Wind 1 has achieved with their proposed routing through the Narrows. However, installing additional future cables needs to be balanced with the growing volume of traffic in New York Harbor and plans to deepen channels to accommodate larger ships. The Narrows is particularly space constrained, but has the capacity for several cables to achieve the 6 gigawatt target if appropriate parallel alignment and spacing principles are applied. Greater constraint on overall cable capacity in Upper New York Bay and adjoining waterways may ultimately limit the number of cables, depending in part on the location of the proposed landfall sites. The feasibility of installing multiple future cables depends greatly on the willingness of agencies and navigational stakeholders to accommodate cables within designated channels and anchorage areas, considering potential minimization and mitigation measures to reduce or offset impacts to the navigational community. Next slide, please. And I believe this is Katie.
So we'll walk through some of the key findings of the overland and landfall area now. The most significant constraints for this particular area are listed on the slide, starting with topography, more specifically slopes greater than 15%, which are prevalent in the zones that traverse northern Long Island. Potential environmental justice areas occur in 23 of the 25 onshore zones, and disadvantaged communities occur in 22 of the 25 onshore zones. These communities rank medium or high in almost all of the zones they're present in, and will be addressed through measures such as multilingual community engagement plans with specific communication and outreach procedures for sharing things like construction related information. Parkways and controlled access highways are present in all of the onshore zones and require additional review and approval for the longitudinal installation of cables within the right of way, as that is considered a non-transportation use. And that review would include both the state DOT as well as the Federal Highway Administration, as both provide fundings for those roads and must also provide authorization prior to cable installation. Lastly, coastal resources include critical species and sensitive habitats like significant coastal fish and wildlife habitats, as well as essential fish habitat associated with the intercoastal bays. It also includes recreational and wildlife viewing. All of those are prevalent along the south shore of Long Island, which I'll show you in the next slide in a graphic. Next slide, please. So this slide provides a couple visual examples of those high constraints I just discussed. The figure on the top shows some of the urban zones in Manhattan, Brooklyn, and Queens, where you can see the prevalence of residential areas in green and the corresponding potential environmental justice and disadvantaged communities, which are there in the red outline polygons. The figure on the bottom shows a portion of the south shore of Long Island near Long Beach and illustrates some of those coastal resource constraints. So the significant coastal fish and wildlife habitats, which are in the aquamarine hatching, and the recreational fishing in the yellow outlined polygons. Also included on this slide are two of the main takeaways from the overland and landfall area. First, that where possible, installation at landfall should be done via horizontal directional drilling because of both the dense urban areas that you will find in New York City, the presence of shoreline protection like bulkheads, as well as to protect the sensitive resources like those present along the south shore of Long Island in the various intercoastal bays. Second, the use of existing electric transmission rights-of-way represent the greatest opportunity to co-locate new offshore wind cables compared to other public rights-of-way. Use of parkways and controlled access highways will require early consultation with DOT, as well as a detailed analysis of alternatives, which should consider environmental, cultural, as well as regulatory factors. Again, due to some of those federal restrictions for non-transportation use that exist for those roadways. Next slide, please. And I'll hand it back to Janine for some of the overall key findings.
Thank you, Katie. As you've heard throughout the presentation of Section 3, the analysis of the most constrained resources reveals patterns and insights for addressing those significant constraints. And the first overall finding is that at a minimum, siting of future multiple cables should incorporate accepted principles based on the cable working group experience and offshore wind industry experience that minimizes the use of space and minimizes impacts on environmental, cultural, and social resources. The ones listed here are a few examples, and there are more listed in the report. Many of these principles, as you heard, were demonstrated as part of the analysis to show that they can be implemented and help achieve the 9 gigawatt goal that the state has. Second, throughout the past year, WSP and the Cable Working Group considered in many ways how to achieve the 9 gigawatts of offshore wind. And as Kate mentioned, try to take into account the beyond 9 gigawatts and potentially 20 gigawatts of offshore wind. The report reflects that forward looking, and from that, it is clear that innovation is going to be required both in design and construction and operation techniques to achieve those goals. As another example, the minimization and mitigation measures that we talked about and implemented in our analysis looked back in terms of precedents from other projects, and it also took a look forward to say, what more do we need to do to meet the state's goal and minimize impacts? And as Steve will show in the next slide, our path to these findings was it really informed by looking at how many cables are needed and where are they likely to go? And in the next slide, Steve will walk through that.
Thanks, Janine. This table, which is presented in the draft assessment report, provides one illustrative scenario for achieving delivery of at least 9 gigawatts with 6 gigawatts into New York City and 3 gigawatts into Long Island. Additional cables may be physically accommodated through some areas, which will be important to consider for potential future targets beyond 9 gigawatts. However, the current scenario reflects inputs during our analysis, including concerns for potential impacts to sensitive resources in Long Island Sound. We assume future circuits would all be HVDC, where each circuit would be a bundled pair of cables in one trench and carry at least 1 gigawatt of power. In addition to the proposed Empire Wind 1 project lines, we assumed 4 future circuits could be installed through New York Harbor via the west side of the Narrows, with a spacing of approximately 50 meters to 100 meters between cables. While space exists for several cables through Long Island Sound, we assumed only 1 future cable in addition to the proposed Beacon Wind project, given the sensitivity and uniqueness of natural resources in those waters. The balance of delivering 9 gigawatts would then require 1 more cable landing along the south shore of Long Island, in addition to a few other projects currently in the works, including Sunrise Wind, South Fork Wind, and Empire Wind 2. I'll turn it back to Janine and Kate to discuss addressing the RFI.
Thank you. Yes, so we really thank everyone for their attendance today, and a reminder, the draft assessment is available and open for feedback. It can be found on NYSERDA's current funding opportunities page under RFI 5166. Next slide, please. And another reminder, the due date for this request for information has been extended from October 14th, which was this Friday, an additional 2 weeks to Friday, October 28th. And I'm not going to read all of the questions here, but just to give you an idea of the type of feedback that we're looking for on this draft. We are asking questions around the accuracy of the information that is in it. Looking for places where information may be missing and where we can find that information, and then how we could make this assessment more useful, and are the ways that it's being presented useful to you. Next slide, please. Okay, so again, the comment period has been extended to October 28th. At that point, NYSERDA will collect, review, and summarize the responses that have been received on the draft and incorporate them into a final offshore wind cable corridor constraints assessment, which is anticipated to be released before the end of the year. Any questions or comments on the assessment can be submitted to oswcablesassessment@nyserda.ny.gov. If you have clarifying questions, you can send them there, and any responses to the request for information can also be sent there. Again, this webinar is being recorded, and the presentation and the recording will be available later this week on the NYSERDA current funding opportunities page under RFI 5166. And at this point, I want to open it up for any additional clarifying questions about what's been presented. I know that we have already a few in the Q&A, and if you could use that to submit any additional questions, we will start looking at those now. So Janine, I think maybe we can start with this one. Can you discuss where a full list of all the resources analyzed as part of the constraints analysis can be found and how that was put together?
Yes, there is an appendix to the report that provides the GIS source data for all of the resources that were analyzed for both offshore and on land. Many of those are actually provided as hyperlinks that you could access if you have the GIS-based software to do so.
Thank you. And a couple of clarifying questions from attendees. We talk about the percent area of each resource. And I wonder if you could kind of clarify how that was used in the analysis.
Yes, I'm going to ask Katie to address that, who led the discussion on the constraints analysis.
Sure. So the percent area is really, it helped us to understand the spatial distribution of a particular resource within either a zone for the offshore or within uh, all of the rights of way within a particular zone. So it wasn't necessarily to look at how much room, but as I said, how prevalent was a particular resource, and that percent area was then used along with professional judgment to assign the ranking categories. So if a resource, for example, had a high percentage of spatial distribution within a particular zone, it may have been given a high ranking. Lower percentages and prevalence within a particular zone may have corresponded with a low ranking. And that, as I said, was certainly adjusted where need be through professional judgment and input from the working group. So I hope that helped to address that question.
Thanks, Katie.
I'll just add to that. I mean, it's if the constraint was high because of the high spatial distribution, it's like saying it would be very hard to put a cable in and avoid that resource because it has a high spatial constraint. The other qualitative factor that we considered was, in some cases, the value of the resource. So if it had a small spatial coverage, but extremely high value, that was to signal that that's also a potential constraint to siting cables.
Thank you. A few more questions clarifying some of the technical things in the assessment. One question is around HVDC and if there are facilities required to convert HVDC to HVAC at some point. And then if this assessment at all examines the ways additional efforts to site those HVDC facilities are being conducted.
Yes, that's a good point. The electricity produced at the offshore wind farm is technically also AC. So to use the DC cable, it's converted there to DC and travels to land, at which point there is typically a converter station, because the same thing happens on our transmission grid that is alternating current. So once we are attempting to connect to the transmission grid, it has to go back to AC. Our analysis did not look at specific locations where converter stations might be located, but we did put that as like a necessary input and the typical number of acres that are required for that resource.
Thanks, Janine. We also have a question about if we considered the use of cable bridges as a possibility and the permits necessary to acquire a cable bridge.
I'm going to start that and ask Katie to jump in, because I think that is most relevant to the coming into the approach areas on the south shore and then the back bays to on land, where again, because we looked at existing rights of way, there was thought, could existing bridges be used, but not construction of new bridges. But Katie, would you want to add to that?
Sure. I was just looking, just to repeat the question for me from the chat. So the question is really focused on oh, I'm sure, here it is. I'm sorry, I see that. Use of cable bridges. Yeah, right. As Janine said, we certainly did consider existing bridges, especially along that south shore. So we try to look at where there is an existing crossing of the intercoastal waters. The assessment doesn't go as far as to say whether or not, a cable would be hung or otherwise affixed to a bridge. Our assessment largely assumed that those would be installed underwater in those particular locations. So again, we didn't go as far as to look at individual crossings and whether or not an above ground cable affixed to a bridge may be feasible, but certainly something that could be considered in the future.
Thanks, Katie. This next question is great at looking at kind of the next steps. This study specifically was aimed around 9 gigawatts of offshore wind coming into New York State. But if, as we said in the beginning, that might increase, how does this study provide a framework for future injection of potentially more offshore wind?
I'm sorry, Kate, is that a question or an observation?
Oh, the question is around how does this provide kind of a framework for understanding additional offshore wind coming into the state greater than 9? If you could talk to that.
Well, the because we weren't looking at specific routes, really these rankings of the constraints are agnostic towards the number of cables. So it is a foundation for analyzing one more cable or 10 more cables or 20 more cables, because those physical resources, either environmental, cultural resources I saw in the Q&A, those resources and their spatial extent will not change.
Thanks. Can you talk about how this assessment analyzes kind of spatially and addresses the temporal effects of laying multiple cables within the same areas? Is it possible to support multiple sequential construction approaches, so building one cable after another? And if that is like technically possible, did we address how we could minimize stakeholder disruption through kind of multiple construction waves?
The temporal effects are not directly analyzed here, primarily because that would be looking more at a specific cable or a specific project. So the impact whenever it occurs is more what we analyzed. And that cumulative effect, or that effect of multiple cables being installed at the same time, would be more of a project specific analysis.
Janine, if I may offer, we did consider the concept of installing, if it's feasible to install multiple cables at the same time by the same installer or the same developer, would potentially allow for tighter spacing logistically, because you know exactly where the cables are being buried at the same time. So there could be some efficiencies in terms of spacing to group those cables somewhat closer together rather than sequential installation, where you have to allow a little more room for error and for the unknown of identifying the location of cable that's already installed.
Exactly. It's one of the things that we put in section 4 for that reason, that is part of the forward-looking concepts and approaches that could reduce impacts.
Thanks, Stephen and Janine. This question is around kind of our stakeholder engagement through this process. And Janine, I know you talked to it a little bit at the beginning of the presentation, and it's documented in the draft assessment. But could you describe a little bit about how we coordinated with state and any relevant federal agencies?
Well, starting with the state agencies, the meetings that were coordinated first with Connecticut Department of Energy and Environmental Protection and New Jersey DEP, the approach that we took there was really to give them a presentation like this in a mid-stage of our analysis, to show them our analytical process And that really introduced an opportunity to exchange information and understanding of those shared resources, since both Connecticut and New Jersey are looking at the same offshore wind lease areas that could interconnect in their states as well. As far as federal agencies, we have talked with DOE through NREL, National Renewable Energy Lab, and we have received comments during the RFI period from Army Corps of Engineers and the Coast Guard. And where it was helpful and relevant, those comments are incorporated into our analysis and addressed. Not to say that there isn't more discussion that needs to be had with them. That was just the beginning.
Thanks, Janine. I concur with you that we're looking for continued input on the assessment and then future aspects of cable work as we move forward. Maybe time for one or two more questions. Another kind of clarifying question about the right-of-ways that maybe Katie could talk to about how the right-of-way categories were chosen for the onshore analysis.
Sure. So we did, as I walked through earlier, we did have 4 rights-of-way categories. Existing transmission line rights-of-way were chosen first as they have the same function and purpose and can allow for co-location of additional lines. Arterial roadways were chosen due to their linear nature and prevalence throughout the study area, and also, the history of siting transmission lines along roadways. Obviously, we did note that certain roadways do carry some greater review procedures with future siting. The MTA lines were actually suggested by one of the cable working group members as an additional linear infrastructure category to consider. So we added those in. We excluded commercial rail just due to some of the increased security that goes along with the review of co-location along those types of rail lines. And then lastly, gas pipelines represent another linear form of infrastructure that certainly can accommodate co-location. So hopefully that helps to address that.
Thanks, Katie. And I think we've got time for one last question, and it's specific about the Long Island Sound, but maybe we could even kind of increase that to other approach areas as well. If there were some resources for which that you found additional data would be needed or recommended.
I'm going to ask Noelle, because I think that is a very relevant question for Long Island Sound in particular. Wondering if you could address that, Noelle?
Sure. So as I mentioned in the presentation, particularly Harbor Hill Moraine and Stratford Shoals, which are areas of increased biodiversity in Long Island Sound, could benefit from some more surveys. There have been a few studies done, but particularly looking at, timing and distribution of species within those areas would be beneficial. And then just environmental studies in general of the area. When we were looking at this, we had to piece together quite a few different studies to try and get a good picture of what was going on in Long Island Sound. But some broader swath studies that have similar survey methods would definitely be beneficial.
Thanks, Noelle. And we just have one more minute. So if we didn't get to your question or you think of something following this presentation, please submit your questions to oswcablesassessment@nycerta.ny.gov. And again, this webinar and the presentation will be available on the RFI page later this week. Thank you everyone for joining us, and especially thanks to WSP, Janine, Katie, Noelle, and Steve for providing this overview today. Thank you.